Our lesson for today is on outcomes. An outcome is something that can happen during a certain event. So today we're going to learn about tree diagrams. A tree diagram is something that kind of resembles a V. It can be up and down, it can be sideways. But let's take a look at what our options are here. What would be the possible outcomes if you spin this spinner? Aiden? You could get that a boy. Now, what if you flipped that coin? What are your possible outcomes? Will? Heads or tails. Now, because there's only two sides on a coin, we know that. So a tree diagram is a diagram that's used to organize how many different outcomes, just like in our problem of the day today. Here we go. We have two possible sample spaces. Now, here's what's going to happen in this outcome. You're going to spin the spinner one time, and you're going to toss the coin 2 times. So, to make a tree diagram, we're going to start by making columns. Our first column is going to be for the spinners. And you told me that there are only 2 choices for the spinner, red or green. Okay, so that's what we're going to list first. Red for one and green for the next. Here we go. All right, only 2 choices, that's it. Next, we'll toss a coin. You told me that there are 2 outcomes for tossing a coin. We can get a heads or we can get a tails. So we list those in our next. Heads and tails for this color, heads and tails for this color. Now if we toss that coin again, the same thing would happen. We would only have 2 possible outcomes, heads or tails. So we're going to list those coming off our second choice. Each of these will come off the second choice. H on one line, T on the next. Now that we have this tree diagram made, it's so easy to make a list of our diagrams. And that way, Sam, you're not going to have times where you accidentally write the same one twice. Because now we start here and we follow across. We start here and we follow across. And now we can list all of our outcomes. Now, if I said to you, how many possible outcomes are there? Well, you could count up if you wanted to, or you could do this. There are 2 choices for the spinner, there are 2 choices for the coin toss, and there are 2 choices for the second coin toss. 2 times 2 times 2. There should be a total of 8 outcomes. Are there? Yes. So we could go green, heads, heads. That's my first one right here. We could go green, heads, tails. See how you follow the path of the tree diagram to make your list, America? What would be the next one? We're starting at the very first thing we did. We're following it. Green, heads, heads. Green, heads, heads. Now we're going to go to the next choice. Green, heads, tails. G-H-T. Ready? Green, tails, heads. What's going to come next, America? Green, tails, tails. Good. So we've got 4 done. Could you do the last 4? Yeah. Who can tell me the last 4? Eileen. Good. Red, heads, heads. Good. 2 more. Red, T, H. And? Red, T. Good work. There are all 8 of our outcomes right there. And we didn't at all have a problem where we accidentally put 2 of the same down. Okay? So, let's take a look at some random examples here. What if I gave you a number cube? A number cube is the same thing as a dice. How many different possible outcomes would there be if I gave you a dice and said, shake it? Aiden? 6. Okay, 6 different things could happen. What if I gave you a spinner and that spinner was divided into white, blue, black, and purple? Emma? 4 different things could happen. It could land on white, blue, black, or purple. What if I gave you a dice again and I said, list the possible outcomes of tossing an even number? An even number. 3, because what are the even numbers on a number cube?
2, 4, 6.
Good work. Okay. Let's take a look at some examples here, and then we're going to make some of our own tree diagrams today. Okay, so I have 2 spinners. I have a color spinner and I have a number spinner. If Mo spins each of those spinners 1 time, what is the total number of different outcomes? We don't have to list them, just how many different outcomes are there? Lingen. What makes you think that? How many colors? How many numbers? We don't add them. What do we do with them? For an answer of 12. We multiply them. We don't add them. Okay, now we have 4 kids, Jack, Anshima, Beth, Juan. They're running for president of their class. Then we have Maggie, Louis, Jenny, and Paul. They want to be vice president. If each kid has an equal chance of being selected, how many possible outcomes would there be? Combinations. How many possible? Natasha? How did you know that? You took 4, since there are 4 presidential hopefuls and 4 vice presidential hopefuls. 4 times 4 is 16. If 10 kids try out for a solo in their choir concert, 6 boys tried out, 4 girls tried out. 1 girl and 1 boy are going to get chosen. Which of the following would give you the number of possible outcomes? Will?
24.
How'd you know that?
6 times 6.
Because there's 6 boys and 4 girls. Good work. Now, think about this one. This is a tricky one. 2 coins get tossed. 2 coins. How many outcomes would be 1 head and 1 tail? This is a tricky one, Aiden. Okay, that's how many possible outcomes there are. But out of those 4, there's 2. You could get 2 different things the first time and 2 different things the second time. 2 times 2 is 4, okay? But now they made it tough. They said, out of those 4, how many of those are probably going to be 1 head and 1 tail?
2.
Just 2 of them, right? Because we're going to have a combination where there's 2 heads and one where there's 2 tails. So you're right, just half. Good job. Okay, tricky one. We have 2 spinners. Which of these spinners would give 6 possible outcomes? Sarah?
8.
Okay. How many here?
2.
How many here? How many? 4. 2 times 4 is?
8.
Ooh, we need 6. A's not going to work. Alexis?
C.
She says C because, how many here?
2.
Times?
3.
Is 6. Good work, Alexis. Good work. Okay, so I would like you guys to open up your iPads, and we are going to start making a tree diagram of our own. Okay. All right. Now you are going to have to write small to make your tree diagram work. So once you have a blank page, I simply want you to look up at me, and I'm going to get you started. I'm going to tell you that in the summertime at my house, we eat a lot of sandwiches at lunchtime. A lot of sandwiches, just because it's easy and quick. So what if I gave you 3 choices for meats? You could do ham, which is an H, turkey, which will be a T, and then let's do roast beef, and we'll make that an R, okay? Then I give you 2 choices for cheese. One is American, which will be A, and one is going to be cheddar, which will be C. Okay? Everybody's with me so far? Now, the first question I'm going to ask is, how many possible outcomes will there be if I ask you that? How many possible outcomes for sandwiches will there be? Will?
6.
Why?
Because there's 3 meat and there's 2 cheese.
So you could have 6 different combinations. Now, let's make ourselves a tree diagram. I will help you get started. Ham, turkey, roast beef. Everybody can put that on their iPad. Spread them out. That is your first set of choices. Now, when I go to my second set of choices, how many choices are there? 2. So I just want a branch that looks like this, because now I'm going to put American, cheddar. American, cheddar. And with this guy, American, cheddar. So far, so good? Now I wish that we were done, but now is the time where we have to make our list of possible combinations. So our first combination is ham American and ham cheddar. I want you guys to do the next ones. All your list needs to be over here. Probably the up and down way, like I'm stacking mine. If you decide to put them side to side, you have to put commas between them or semicolons so that we can tell how they're divided up. When you're done, please check your answers with mine. Next example for you is this information. I am going to give you some clothing options for when I get dressed in the morning. I can either wear jeans, I can wear khakis, or I can wear sweats. Okay? That's for my pants. Now for tops, I can either wear a t-shirt, a sweater, or a jacket. For shoes, I can either wear heels or I can wear flats. Question number 1. How many different combinations will I end up with? How many different combinations? Kaden, tell me how you found that. 3 times 3 times 2 gives me 18. Now, I'm going to give you guys some time, and I'm going to help you get started, and I want you to help me make a tree diagram for that information. First, we're going to have khakis, jeans, and sweats. Separate those up so you've got plenty of space to work with. Now, how many branches are going to go off of my pants? 3. So here's what a branch with 3 looks like. Okay, we had a jacket, a sweater, and a, what was the other one? I gotta go back. T-shirt. Okay, same thing here. J, S, T. We'll put them in the same order. J, S,